This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest is Laura Bofferding, who's an assistant professor of mathematics education in the Department of Curriculum and Instruction at Purdue University. Laura, thanks so much for being here.
Thanks for having me.
We're going to be talking about Laura's article in the current issue of the Journal for Research in Mathematics Education, and the article's entitled Negative Integer Understanding, Characterizing First Graders' Mental Models. And Laura, this article comes from your dissertation, so I want to start by going back to your graduate school experience and asking you where you did your studies and who you worked with.
Sure. I did my graduate studies at Stanford University, and I was working with Aki Murata, who was doing some work on subtraction and lesson study. So my work on negative numbers kind of took a little detour from the stuff I had been helping her out with, but is still related in terms of focusing on numbers and operations.
Yeah, so what was it that really motivated you to look at integers, negative integers in particular, and in the context of first grade?
Yeah, so I was helping teach one of the math methods classes for the pre-service elementary teachers, and in one of the classes they wanted to know how to teach negative numbers. So we did a class where we explored the two kind of prevalent models for teaching cancellation and using the number line. And as we were going through the different types of problems, they were bringing up lots of questions that really got me thinking about, how on earth do children ever make sense of this? Because it's hard enough for us to make sense of these models. So then I started doing some pilot studies with children between 2nd and 5th grade, actually, and found that even some of the 2nd graders had some intuitions and some ideas about negative numbers and some kind of interesting ways of thinking about them. And so I decided that I wanted to look at more how these initial ideas develop, which is why I chose to go with first graders in the hopes that even fewer of them would have heard about them, so that I could really get at where do you go when you haven't heard about them and then you do, and how does your thinking change?
Yeah, that is really interesting, and I think the departure into negative numbers is such an important thing in mathematics, and it's similar to things that are going to be happening all the way throughout, this kind of pushing the boundaries of mathematical objects and pushing them into new realms.
Right, and really thinking about the relationships among numbers. And knowing about negative numbers, I think, can really give you a different type of number sense than when you don't know about them. And you can solve subtraction problems in a different way than you would have if you hadn't known about them.
So in the study, you used this idea of mental models as a kind of a framework for your research. So I was wondering if you could just tell us about how you think about mental models.
The way I think about mental models, I guess, is drawing on the work of Wozniacki and her colleagues who did a lot of this work in science and have kind of more recently shifted this type of thinking into mathematics. And they really talk about it as children develop these initial mental models about concepts based on their experiences in the world. So for children with number, they learn about whole numbers by, experiencing objects and seeing objects, and they develop the understanding of concepts of quantity and order based on, these manipulations they do with objects and hearing people talk about them. So their mental model is really the understanding of the concepts and the relations among these concepts that they get. And they kind of develop some rules based on their interactions with these concepts. And so Wozniacki also talks about how, in order to learn new concepts, then you use your initial mental model or your initial way of thinking about these ideas when you encounter something new. So you don't necessarily take on negative numbers right away. You kind of try and force them into how you were thinking about positive numbers. But over time, and after working with them and hearing people talk about them, having instruction with them, then you start to kind of try out both of those ideas together. So you're starting to acknowledge that this negative number is something different, but still trying to fit it in with how you were working with positive numbers. So you sort of get it, but all of the relations aren't quite there. And then, with more work and additional instruction, then students will start to move towards the more formal way of thinking about it, developing that formal mental model. So it's really looking at the changes in how they think about different concepts and the relations that they put amongst the concepts, if that makes sense.
Mm-hmm. It sounds like it's kind of Piagetian based. Is that true, that it kind of comes from that sort of learning theory tradition?
I think the way that they would talk about it, to some extent, yes. They may put a bit more emphasis on kind of formal instruction, I think. Okay,
which actually then brings us to your study design, because you actually did design some instruction to go on. So overall, your study had a pre-test, and then it had this instructional sequence that you designed, and then a post-test following it. So could you tell us about that instruction and how you designed it, and what were the main characteristics of it?
Sure. So when I was looking through the research, one of the big themes that stuck out to me was this idea that when children are learning about negative numbers, they have to rethink this notion of the minus sign. And the minus sign could really take on several meanings now. So before it just meant subtraction. And now they also have to understand that a minus sign right in front of a number designates a negative number. And that negative number has a whole different type of meaning now than the whole number did. So a lot of instruction kind of addresses this, but in a very subtle way, and it's not made obvious to students. So when students have to deal with the different meanings of the minus sign once negative integers are introduced, they have to, one, understand that with a negative number comes additional order, so you have to extend your order of the whole numbers down below 0. And that this order is kind of symmetrical around 0 in a sense, except for the addition of the negative sign. And that the values continue to get smaller in relation to positive numbers. So it's like an extension of this number line. And then when we think about how their interpretation of subtraction needs to change, and when I say subtraction and the subtraction meaning of the minus sign, I'm also kind of lumping in the new meaning of the addition sign. So before, with positive numbers, adding meant getting more of something, subtraction meant getting less of something. And this is how children will talk about it as well. Mm-hmm. And so I was interested in, how do we extend this idea of more and less with children and the way they're thinking about it into negatives? And what they really need to be able to understand is that you can get more negative and you can get less negative, just like you can get more positive and less positive, either of something or in a direction if you're thinking about movement. Mm-hmm. So what I was interested in doing, since a lot of this instruction that I'd been reading about, they either don't address explicitly this idea that you can now get more and less of positive or negative, or they don't explicitly talk about, oh, hey, you're seeing this minus sign two different ways, and now we need to really talk about what that means. I wanted to see, if we introduce students to the negative meaning of the minus sign, how might that change their mental models? And would that extend into their thinking of addition and subtraction could go in both ways? Or what if we just introduced this idea that we can move more positive, less positive, more negative, less negative? Just working with that sort of idea, would it help them make some sort of sense of what negative numbers are? So one of my instructional groups just focused on the unary meaning of the minus sign, which is the negative meaning of the minus sign. We did activities where students had to order negative numbers. We played games. We talked about which was more and which was less, and they played games around that idea. And we also did a lot of work on how do we tell if it's a subtraction sign versus a negative sign. And then in the second group, we really just focused on what does the movement more negative look like compared to more positive look like. And we moved back and forth on the number line playing different movement games. And then the third group had a combination of activities from both of those two groups. So really looking at how might their mental models change if they had both experiences instead of just one.
Okay, and so you had a pre-test administered before this, you had the instruction, you had the post-test. Could you just quickly kind of let us know what the data were that you were looking at?
Sure. In the pre-test and post-test, I had a bunch of questions that would help me try and make sense of what their mental models might look like. And so that involved having several variants of questions around integer order. So count, how far can you count backwards? If they'd stop at 0, I'd kind of prompt them to keep going. They'd order integers in a couple different contexts. There were several different questions where they had to say which integer was more or less. And we did some of that just by presenting integers, and some that were presented within a context of, who's winning this game, and this person has, -5 points, this person has 2 points, that sort of thing. And then there were questions where they had to move this cat either more high, less low, and talk about kind of those relationships of thinking about more and less in different directions. And then on the post-test, I also had questions like that with more positive, less positive. So then having several variants of those questions allowed me to look at kind of general patterns in how they were responding so that I could characterize a mental model based on that.
I'm speaking with Laura Bofferding from Purdue University about her article, Negative Integer Understanding, Characterizing First Graders' Mental Models. So when you looked at that and you were trying to look for those patterns and building the mental models that the first graders had, what were some of the models that you saw?
Sure. So again, as I was kind of analyzing this, I was drawing on the 3 main categories that Wozniacki had, which was initial, synthetic, and then formal. So for the initial, I was looking for students who were pretty much treating negative numbers as positive numbers. And I found 2 kind of variants of this. So some students, in one, which I classify as whole number mental models, they ignored negative signs, called them positive numbers, treated them as positive numbers in every way across all of the questions. Then there were some who would order the negative numbers separately from the positive numbers, and sometimes it looked like they were doing so correctly. But when you talked to them about the values, it was clear that they were treating them as if they were positive numbers. So it was almost like they were sorting them separately, almost like, if you had a pile of red and blue numbers and they just, kept them separate, but still interpreted them as the same thing. So in terms of order and value, we had students treating them as a whole number, or I called the second one kind of an absolute value. And then in terms of synthetic mental models, there were students who would order the negative numbers below the positive numbers, and they would talk about negative numbers being less than positive numbers. But they would flip the order of the negative numbers. So -5 to them was bigger than -3. And in some sense, this is, a correct way of reasoning in some contexts, but in the way that we were using it, it wasn't quite to the formal level, and they couldn't think about it flexibly either. And then for the formal level, these were people who all of their responses were correct, and they could talk about negative numbers being smaller than positive numbers. They could talk about kind of the flipped version of numbers, so -5 looks like it's big, but it's actually really small. So they could kind of talk about those interesting relationships. And then one thing in terms of the order and value I also found was that there were what I found to be kind of transition categories between Wozniakki's 3 levels. So there were some students who they weren't quite just thinking about it in terms of whole numbers, and they weren't quite thinking about it in terms of the magnitude synthetic model. So I put them kind of in between, and these were people who sometimes were treating them as positive numbers and sometimes treating them as something different. And a typical response there would be students who were interpreting them negative numbers as 0. So they would often order negative numbers less than 0, but talk about them as being equivalent to 0. And then there were students who were always ordering negative numbers less than 0, like the synthetic group was, but sometimes would order them correctly and sometimes order them flipped. So sometimes they would talk about -5 being greater than -3, and sometimes talk about -3 being greater than -5. And it was almost like they were still trying to make sense of which was correct. Mm-hmm. So that was the order and value. And then in terms of thinking about kind of directed magnitudes and this idea of being able to move less positive, more positive, again, they kind of fell into the main 3 categories that Wozniacki had, and I didn't find any transition categories there. So at the initial level, students would either just kind of guess a direction or always move the cat higher or always go in one direction. Otherwise, students would tend to focus on whether they were going more or less. And they kind of categorized this number line around 0. So if you think about 0 and moving right on the number line, which would be getting more, they kind of had more high would be furthest to the right, and less high would be just to the right of 0. And then if we go just to left of 0, that would be less low, and then more low would be even further to the left. So they kind of had parceled out the number line in thinking about direction. And then at the next level, the synthetic level, I saw students who were starting to make a bit more sense of what more low could be. So they were starting to kind of cross over and think about that sort of thinking. And then at the formal level, students were able to say things like, less low is actually getting higher. So they were able to see how kind of, in a way, almost two negatives make a positive, like less low is actually more high.
Right, starting to see the equivalence of those.
Yeah.
Okay. So having that range of the mental models that you identified in the students' thinking and reasoning about integers, I'm now curious about the pre-test to the post-test, and if you're able to kind of notice some changes, and then are you able to any degree attribute that to the instruction, where you had the instruction on unary meanings of the minus sign and binary meanings of the minus sign?
Right. So on the pretest, the majority of students had what I classified as a whole number mental model, so treating the negative numbers as if they were just positive numbers. And of course, there were a few who, were at different levels, but about 70% of the students were kind of at that initial level. On the post-test, though, and this is in relation to the order and value mental models particularly, the students who had had instruction on the unary meaning of the minus sign, so what is a negative and what is the order and the value, those students significantly improved to the point where they were developing formal mental models, so they could talk about the order of the negative numbers and the values in relation to positive. And a few of them were kind of in that transition mode, where they were almost at a formal mental model, but still kind of trying to make sense of which direction the negatives go in and which negative is larger than which other negative. Mm-hmm. And that the same thing with the group that had the combined instruction. So because they had the instruction on negatives, they also significantly improved in terms of the order and value. Now, the group that had just worked on kind of the movement, more positive, less positive, they tended to stay at the initial level. A few of them moved towards sorting negatives apart from positives, but still treating them as negatives. And a few of them moved towards understanding that negatives are less than positive. So it's interesting that even though we never really talked about that, a few of them did kind of pick up on that based on the movement across 0. And it was, a little surprising that a few more didn't pick up on that because of the counting we did above and below 0 and the movement that we did. But it wasn't as significant compared to the other two groups. However, if we look at the changes in their mental models for the directed magnitude kind of thinking, the group who had that instruction did significantly improve in developing formal mental models compared to the group that just had instruction on negative numbers and what they are in terms of order and value. So that group kind of stayed at a synthetic level, which is where most of them had started out on the pretest. And again, the combined group also saw the benefit of having that instruction. Although, what was interesting about this is I looked at their mental models for the directed magnitude in terms of the questions that focused on more high, more low, and less high, less low, separately from the questions for more positive, more negative, less negative. Mm-hmm. And while they made significant gains on the more high, more low, it was much more striking in terms of the number of students who had direct formal mental models for directed magnitude for the more positive and more negative. And I think that's because that was the language we used in the instructional activities. So this language is really hard for them to get, like this idea of less low, what does that mean? But because we used less negative in our instruction and in our movements in the games, I think that's one reason why I saw I saw more students having formal mental models for the groups that had that instruction than I did for the less low, less high. So kind of that language issue might be something interesting to keep looking at further. Mm-hmm. But really, it was encouraging to see that all of the students benefited from their instruction, and I think this really points to the idea that first graders can handle this. And I think, we'd seen some people reporting on, a kindergartner could do this, a first grader could do this here and there in the literature, and, there'd been kind of anecdotes from teachers who talked about, talking about negative numbers with her class, but this really showed, a whole class of students could progress when given pretty simple experiences playing games with the activities and really just talking about them, having that chance to kind of problem solve through what these different meanings on the minus sign are, or what does it mean to add in one direction versus another direction.
Mm-hmm. So staying right along these same lines, I want to get you to say a little bit more about the implications that you see for teaching, especially since going back to kind of what you said at the beginning about how it was from thinking about the teaching of integers and how it can be potentially confusing to now having gone through this instruction and looking at the results that you have here. What would you say are some of the implications for teaching?
Yeah, I think one thing that I hope people get out of this is, first of all, we can expose children to this idea a lot earlier. Like there's no need to pretend that they don't exist. And one of the things that students really struggled with was thinking about problems like 3 minus 5, which isn't talked about in this article, but a lot of students would tend to say things like, you can't do that, because they've, whenever they've done subtraction, they haven't talked about negative numbers, so with positive numbers you can't. So they would answer 0, or they would change the numbers around, so 3 minus 5 became 5 minus 3. So they do kind of these weird things, whereas, if we just introduce them to the idea, maybe we could help them get over that belief that you can't solve these types of problems, which in the literature we see even reappearing in 5th grade, 6th grade. It's kind of persistent because it's been something that they've experienced from a really young age, and it hasn't ever been contradicted. So that's one implication I see. Another is really paying particular attention to the meanings of the minus sign and really addressing it. So in all of the instruction, the traditional number line instruction does this to an extent, but kind of gives weird meanings, like kind of fake meanings to the meaning of subtraction and negative. So there's this idea that a negative sign means turn around, and then a subtraction sign means move backward, almost like if you were picturing yourself standing on the number line. And that's students kind of forget that rule. It doesn't really make a lot of sense to them. Whereas in like the cancellation model, the idea of focusing on the difference between a negative sign and a subtraction sign doesn't really come up. Because you're dealing with these kind of objects. So being really cognizant of the fact that when students see these two things together, a minus sign and a negative sign, they have a really difficult time figuring out what's going on there unless you've really talked about it. So just being really explicit about that. And then also the piece that's really not talked about much at all in the instruction currently is the idea that addition means more, but you can get more positive, you can get more negative. Just like you could get more happy or you could get more sad. So really thinking about what the meaning of addition is and presenting it in a way that would be consistent even when we introduce negative numbers.
So just that subtle difference between bigger and more, and how that really makes it a big difference.
Yeah. And I think the other implication here is the students seem to do really well with this kind of movement context that they had in the binary group. And, one of the contexts we don't talk about a lot, at least in the United States, is kind of that distance meaning of subtraction, which I think becomes a lot more natural when you're thinking about negative numbers. And if I'm at -3 and I need to get to 5, what does that mean? So I think that could be another way to really help students make sense of negative number subtraction.
Mm-hmm. So what are you working on next? Or do you have something else that you are kind of investigating to follow this up?
Yeah, so because I did pretty explicit instruction with the students, and then, they played games based on that, and we really talked through the games. I was interested to see if kind of a less formal context would have similar games. So I'm currently doing a study as part of my National Academy of Education Spencer postdoc fellowship on kind of the use of informal board games and how that might help them think about negative numbers. So it's kind of an extension of Bob Siegler's board game studies, where children are counting from -10 to 10 along, just a linear board game, and seeing if that experience of counting and experiencing quantity in that sense, quantity of movement along squares and saying the numbers that they pass through, gives them some sense of the order and the value of negative numbers. And I'm doing that with first graders. I did it with first graders at the beginning of this year, so it's at the beginning of their school year, which is also different from my dissertation work, which was at the end of the first grade year. And then next year I'll be trying the same thing with kindergartners. And so what I'm doing here is really looking at, do you have to have some pretty solid positive number sense before learning about negative numbers, which I would expect with the first graders. They already knew the order and value of positive numbers, at least for 1 through 10. Versus next year with kindergarten, where they're just starting to make sense of all of that, can they also make sense of negative numbers at the same time?
Well, we'll be very interested to see what you find there, too, as you continue this work forward.
Thanks.
The last question I want to ask is the one that I usually end on. It's from my friend Aaron Brackenecki. He is the inspiration behind this question. But,
Okay.
You've started your career at Purdue. You've got a lot of things going on. You have this great article in Jeremy, so congratulations on that. But I
Thanks.
want you to imagine an alternate universe where you actually are not in a career of math education.
Okay.
What do you, in that alternate universe, what do you see yourself doing?
Well, people who know me well know that I'm really obsessed with children's books. So I think I would probably be a children's book author.
Now, would some math squeak into your children's books? Or would
Probably.
these be...
I don't know that I can ever completely get away from it.
Yeah. What's one of your favorite children's books yourself?
Oh man, that's hard. I'm a really big fan of Dr. Seuss.
Yeah, he's got a lot of wonderful stuff.
Yeah. One of my favorite math-related Dr. Seuss books is 10 Apples Up on Top.
My guest has been Laura Bofferding from Purdue University. Thanks so much, Laura, for being here.
Thank you for having me.
Thank you for listening to this episode of the Math Ed Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.